All right, we are officially on our last unit of the semester. Over the last month or so, we've been dealing with solving quadratic equations. And now we're going to graph quadratic equations. So let's go through a couple things first. Here is our general formula for a quadratic equation. F of x equals ax squared plus bx plus c. Remember, this is in standard form. And f of x is the same as y. Okay, f of x is the same as y. Typically, if it's in function notation, you're going to plug something in for that value of x to solve for the y value, which we'll get to when we start actually graphing and using our table of values. When we do the graphing for quadratic equations, all of our graphs will be parabolas. Okay, all of our graphs are going to be parabolas, and I am one you focused on linear graphs, so straight lines. Here with quadratic equations, we're going to look at parabolas. So let's go through some vocab. So again, our graph is going to be a parabola. And for our purposes, there's two ways that this graph is going to open. Our graph is going to open facing up, or our graph will open facing down. Okay, this is known as the orientation of the graph. So if you see orientation, you're going to say up or down. Now, orientation is all dependent on our A value. So whatever your A value is will determine your orientation. If A is positive, my graph will face up. And if A is negative, my graph will face down. Okay, so a positive A value gives an orientation of up. A negative A value gives you an orientation of down. Okay. Another super important piece on a parabola is the vertex. And this is going to be known as your peak point. We'll talk specifically about what you'll see. But again, we have two ways that our graph is going to open. So if our graph opens up, our vertex is going to be down at the bottom of our graph. And this is going to give us a minimum point or minimum value. Okay, so if your graph opens up, which means your A value is positive, you're going to have a minimum value at your vertex. If your graph opens down, your vertex is going to be at the top, giving you a maximum point. And when we talk about the maximum or minimum value, okay, so the maximum or minimum value, hold on, this is a little blurry, let me. There we go. Maximum or minimum value, we are specifically talking about the Y value of the vertex. Okay, so maximum would be its highest point, minimum would be its lowest point. And again, specifically, it's the Y value of the vertex. Okay, so again, orientation tells us if our graph opens up or down. We have maximum and minimum values. If our graph opens up, meaning our A value is positive, we're going to have a minimum. If our graph opens down, meaning the A value is negative, we're going to have a maximum point for our vertex. Now for every parabola, again, there's a vertex, and through that vertex, we have a special line known as the axis of symmetry. Now the cool thing about parabolas is they are symmetrical on both sides. So if you were to fold your parabola, and obviously if it's drawn super accurately, if I were to fold my parabola along the vertex or this axis of symmetry, these two halves would completely meet up. Okay, now there's an equation for the axis of symmetry. So here, our maximum and minimum values were based off the y value of the vertex. Our axis of symmetry is always the x value of the vertex. Okay, our axis of symmetry is always going to be the x value of the vertex. And I said there was an equation. It's always going to be x equals whatever number that is. Okay, whatever number the x value of the vertex is, that's going to be your axis of symmetry. Now, you'll notice that this is a line, and this line is vertical. So if you remember from IM1 when you were graphing vertical lines, it was always x equaled a specific number. And in this case, it's going to be the x value of our vertex. Okay. Last thing I want to talk about vocab-wise for the time being is the domain and range. So just a reminder, domain is all x values. Okay, the domain's all x values. Now you'll notice that I have arrows that on the ends of my parabola, and when I'm on a coordinate plane, it's going to continue forever out that direction. So my domain is going to be all real numbers, and we write it like an R but with an additional line through it. If you want to write all real numbers, you can. So all real numbers. For parabolas that are in this form, your answer for domain is always all real numbers. We also have the range. Okay, the range is the one thing we're going to have to think about a little bit, but still it should make sense to everybody. So first of all, the range is going to be all of your y values. Okay. And there's two ways that you're going to write the range depending on what your graph looks like. So the first one is going to be y is greater than or equal to a number. The second one is y is less than or equal to a number. So let's think about what would happen in both of these situations. So if y is greater than, that means all the numbers are going to be higher than whatever number that is. They're getting larger, they're greater than. So in this case, if you notice when I have a vertex, that's a minimum point, my graph continues to go up. Okay, so this is when you have a minimum. You're going to use y is greater than or equal to that number. And if I have a maximum, my values go down. So that's where the less than comes from. So they start here and they decrease. So this is where I have a maximum value. Now we're going to go through this a ton of times, but this vocab is going to be super important. We'll go through one other set of vocab as we go through these problems. But let's start by graphing. So before we do anything, we are going to use a table of values for this unit. We eventually will have you create your own. But for now, we're going to use a table of values. And we're going to graph the function f of x equals x squared. Now this is known as a parent function. And in this particular case, our a values, so remember a is the number in front of x squared, right? So if we come back up here, a is in front of x squared. So a in this case is 1. Okay, so my parent function has a value of a equals 1. Now I've created the table of values, and we're literally going to plug everything in. That's what function notation gives us. It tells us to take the values for x and plug them in. So if I plug in -2 for x, -2 squared, -2 times -2 is a +4. Okay. If I plug in -1, -1 times -1 is a +1. If I plug in 0, 0 squared gives me 0. If I plug in +1, +1 squared is 1. And if I plug in 2, 2 squared gives me 4. Okay, remember up here we talked about how the axis of symmetry goes through the vertex, and on either side of that axis of symmetry, that parabola is symmetrical. So if we look at our table of values, and I look at this point here of 0, 0, on either side of 0, 0, those points are symmetrical, which means 0, 0 in this case is going to be my vertex. Okay. So my vertex, and it's a point, is the point 0, 0. Now we'll talk about all of the vocab in a second, but let's plot these points. So -2, +4. -2, 4 is my first point. -1, 1 is my second point. 0, 0 is my next point. 1, 1, and 2, 4. Okay, again, you're going to see symmetry. They're going to line up, because if I was to fold along that vertex or the axis of symmetry, everything's going to match up. Now, the big thing is you draw in your parabolas, because you want to be as accurate as possible. Sometimes it doesn't work, but what you don't want is a V. These are all U-shaped graphs. So you want to make sure they all curve as nicely as possible. And again, you're extending through. That graph goes on forever, so you want to have your arrows in there, but it should be a U-shaped graph. Okay, so we have our U-shaped graph. We already talked about what our vertex is. I want to continue going through our vocab. So let's talk about the orientation. So the orientation of this graph. So we already said A was 1. A is a positive value, and our graph faces up, which is obviously something that you see once we graphed the parabola as well. So the nice thing about all of this vocab is we could ask you these questions, and you could name all of this information before graphing. The graph helps solidify whether you did that appropriately. Okay, so we talked about orientation. Let's talk about whether we have a maximum or a minimum. So again, our graph, our parabola opens up, which means my vertex is a low point. So I'm going to have a minimum value. Okay, so I have a minimum, and that actual minimum value. So remember up here we said the minimum is the y value of the vertex. So if my vertex is 0, 0, the y value of my vertex is 0. So it has a minimum value at 0. We also have the axis of symmetry. Which I'm going to start abbreviating as A of S, just to fit things a little bit nicer. So the axis of symmetry. So remember, it goes through your vertex. It's a vertical line through your vertex, and it's always the x value of the vertex. So if my vertex is 0, 0, the x value is 0, and we're going to write it as an equation. So x equals 0 is my axis of symmetry. It's the line that literally goes through, you can kind of see my dashed lines, literally goes through your vertex. Let me do it in highlighter and see if that works better. There we go, that's a little better. Okay. And then the last thing we need to identify is the domain and the range. So the domain for all parabolas, for everything, is always going to be all real numbers. Okay, you don't have to think hard. That one should be a given. The range we do have to think about a little bit. So here's our lowest point. Our vertex is our lowest point. All the values get greater. Okay, all the values are greater. So y is greater than or equal to. And my lowest point is my minimum value. So everything is going to be greater than or equal to 0. Okay, so I start at my vertex. Everything is greater. So y is greater than or equal to. And it's going to be your minimum value in this case. Sometimes it'll be your maximum value if everything gets smaller. Okay, so you need to be able to identify all of these features. You need to be able to fill in a table of values and then obviously do a graph. All right, our next function changes a little bit. We notice that here my a value is now 1/2. A is 1/2. So here's another bit of vocab for you. When a is less than 1, when a is less than 1, and when we're talking about a being less than 1, actually I'm going to change that because I think it'll get confusing. When a is I can't do it without scratching it out. I'm going to do it like this. When a is between 0 and 1, we have something called a compression. And more specifically, it's a vertical compression. So we'll see what actually happens. Okay, so I have a vertical compression when a is between 0 and 1. Now, if your a value is negative, you're going to ignore the negative sign and you're going to see if the actual number is between 0 and 1. The only thing the negative does is tells you the orientation. Okay, and we'll get to some of those problems. So, again, we have a vertical compression when a is between 0 and 1. So in this case, it's 1/2. All right, let's fill in our table. So I want to fill in 1/2 x squared. So 1/2 and then -2 squared. Make sure you are doing the -2 squared first. So -2 squared is 4. And then 1/2 times 4, or half of 4, is 2. Okay. 1/2 times -1 squared. So I really have 1/2 times 1, because -1 squared is 1, and half of 1 is 1/2. Or I'm going to put 0.5 here because it will be easier for us to graph. If I plug in 0, 0 squared is 0, times 1/2 is still 0. If I plug in a positive 1, 1 squared is 1. 1/2 times 1 is 0.5. Are you seeing some symmetry? So here's going to be my vertex, and then on either side is symmetrical. So without doing math, I can pretty much assume that this is going to be 2, but let's just make sure, because maybe we did our math wrong up here. So 1/2 times 2 squared is 1/2 times 4, and half of 4 is 2. Okay, so there always is going to be some symmetry there. All right, let's take a second and plot those points. So I have -2, 2, -1.5, so I'm going to go halfway through the box. 0, 0, 1.1, and then 0.5, and then 2, 2. We're going to draw in our parabola. You should have something like this. Okay, so looking at our parent function when a equals 1 versus our function when a was between 0 and 1, you should notice that your graph got wider. So I called it a vertical compression. So if I were to take this parent function and I were to push it vertically, what's going to happen? It's going to flatten out like this one did. So with a vertical compression, my graph is going to get wider. So when a is between 0 and 1, my graph is going to get wider. Okay, let's identify the vertex. So if I look down at my table, remember my vertex is going to be have symmetry on both sides of it. So if I look at 0, 0, I have a 0.5, 0.5, and a 2, 2. So that tells me my vertex is at 0, 0. The orientation of my graph is up. A is positive, so the orientation is up. And if the orientation is up, it means I have a minimum value. The minimum value is the y value of the vertex. So if I come over to my vertex, the y value of my vertex is 0. I need an axis of symmetry. So the axis of symmetry again is the line that goes through your vertex vertically. It's always going to be x equals, and if we come back up here, it's always the x value of the vertex. So x equals 0. I have a domain, and for quadratics, for our purposes, for all of these, our domain is going to be all real numbers. And my range, so I have a minimum value, everything increases. So it's y is greater than or equal to, and it's going to be greater than or equal to that minimum value, which is 0. Okay. Last one. Here we'll notice that a is 2. Okay, so we dealt with a when a is 1, that's going to be our parent function. When a is between 0 and 1, we have a vertical compression, so my graph's going to get wider. Here, when a is greater than 1, we have a vertical stretch. Okay, we'll see what happens with that, but you can probably guess from the word stretch what's going to happen. All right, so we want to do 2x squared. So let's see what happens. 2 times -2 squared. So again, you're dealing with your squareds first, order of operations. -2 squared is 4. 2 times 4 is 8. Oops, that should be a 4. This should be an 8. There we go. Next, we have 2 times -1 squared, or 2 times +1. -1 squared is 1. 2 times 1 is 2. If I plug in 0, 0 squared is 0, times 2 is still going to give me 0. I'm going to plug in 1. So that's 2 times 1, which is just 2. And again, there should be symmetry. So this value should be 8. Let's see. 2 squared is 4. 2 times 4 gives me 8. Okay. So let's graph these points. All right, so I'm going to plot the point -2, 8. I'm going to plot -1, 2, 0, 0, 1, 2, and 2, 8. Now again, we're going to try to be as accurate as possible when we graph our parabola, and we're going to create that U shape. I got a little wonky, but that works. Okay. So here we had a vertical compression. If we press down on our parent function, our graph gets wider. Here we have a vertical stretch. So if I were to pull this up vertically, it's going to get skinnier, which is what happened with this graph because A was greater than 1. All right, I want you to pause the video for a second, and I want to see if you can identify the vertex, the orientation, a maximum or a minimum value, the axis of symmetry, and the domain and range. So pause for a second and see if you can do that. All right. Hopefully you took a second to see if you can identify everything. So the first thing we're going to identify is our vertex. Remember, there is going to be symmetry around your vertex. So if I look at my table, or I can even look at my graph, right? This point here is going to be my vertex, which is at 0, 0. But there is symmetry around it. The orientation of my graph is that it's facing up. Because it's facing up, I have a low point. So I have a minimum value. And that minimum value is the y value of my vertex. So my minimum value is 0. My axis of symmetry goes through the vertex vertically. And that is going to be x equals the x value of my vertex, which is 0. Domain for all of our quadratic equations is going to be all real numbers. And then my range, I have a low point, and everything gets higher or is greater than. So y is greater than or equal to that lowest point, and that lowest point is our minimum value, which is 0.